This week in lab, we are going to be talking about forces. You can think intuitively about forces as either a push or a pull. And today, or at least for this lab that we're going to be working on this week, we're going to be thinking about forces as a pull. What we're going to have is 3 forces pulling outward from a central point. And all of those forces are said to be in equilibrium if the sum of all of those forces equals 0. So forces are a vector. They have a magnitude and a direction. So here we're going to be talking about forces and thinking about our vector addition problems again. Okay, so I'm going to work through a couple of the problems here that you have in your pre-lab, and then you're going to model the same method that I use here, just with different numbers, in order to work through the pre-lab. Okay, so here's one of your problems. We have 2 forces that I'm going to call force F1 and force F2. Okay, they're going to be written like this in the pre-lab. You're going to see that force F1 is equal to AX I hat plus AY J hat. Remember that these hats here, these I hats and J hats, these things are what we call unit vectors. Unit vectors are essentially telling you that your vector component, the quantity that's in front of the I hat or J hat, is acting along a particular axis. So here for the I hat, that means that the quantity in front of there, that's the component of my force F1 in the x direction, okay? And then if the quantity is in front of J hat, that tells us that that's the quantity of our force in the y direction, okay? And so then you will see that in the Canvas quiz that AX will be equal to something, AY will be equal to something, BX will be equal to something, BY will be equal to something, which is our x and y components for force F2, okay? And so I've written out those forces F1 and F2 in our unit vector notation, our vector notation. Canvas gave me 4 quantities, one for AX, AY, BX, BY, okay? So my F1 force F1, whenever I take those quantities that Canvas gives me, I can write out my force F1 in its vector notation. And so here for me, my force F1 is equal to 6.45 I hat plus 8.32 J hat, okay? So remember, this is the x component, this is the y component, okay? And then we've got our force F2. This force is minus 3.8 I hat plus 2.58 J hat. Okay, so this is the component of my force in the x direction for F2. This is the component of my force in the y direction for F2. Okay, so now we've got F1 and F2. We have to determine what the force F3 is such that the sum of our forces F1 plus F2 plus F3 equals 0. How do we do that? Well, to do that, we're going to break up our vectors into their x and y components, okay? And so what I can do is I can say that the sum of all of my forces in the x direction has to equal 0, and the sum of all of my forces in the y direction has to equal 0. Then I can solve for the x component and y component of F3, and then I can get my vector F3 from there. Okay, so what does this look like? I'm going to say that the sum of all of my forces in the x direction must equal 0. So this symbol that I make here, this is a capital Greek letter sigma, and that means sum, okay? So the sum of all the x components of my forces in my problem must equal 0. So that means that F1x plus F2x plus F3x must equal 0, okay? Or if I'm going to write it the way that I wrote these vectors here, I would say that AX plus BX plus, let's call the x component of F3 CX must equal 0, okay? And I can do the same thing for the y component. So the sum of my forces in the y direction must equal 0, okay? So that's F1y plus F2y plus F3y equals 0. So then I can say AY plus by plus cy must equal 0, okay? So since I gave ax and ay to f1, bx, by to f2, we can say that f3 will equal cx I hat plus cy j hat, okay? So now we can solve for the components, the x components of my third vector right here, the x component and the y component of my third vector here. Okay, so I'm going to solve this equation for cx. That's the x component of my third vector. So I'm going to move all of these two terms to the other side. So cx is equal to minus ax minus bx. And I'll do the same thing for cy. cy is equal to minus ay minus by. Okay? So then I have that this is equal to minus, my ax component was 6.45, minus my bx component would be minus 3.88. Okay? And so then I have minus 6.54 minus negative 3.88. When you've got two negative signs here, that becomes a positive. And so this quantity becomes minus 2.57, okay, and that's cx. And then for cy, I've got minus, my ay component is 8.32, minus my by component is 2.58, so this is equal to negative 10.9 for cy, the y component of my third vector here. So now if I write my vector f3 in its unit vector notation, we see that f3 equals minus 2.57 I hat minus 10.9 j hat. And so what you are going to be asked for is the x component of this third force right here. So we were asked to determine the third force needed to make the sum of F1 plus F2 plus F3 equal 0. Okay, and since I can't ask you for both the x and the y component of this force, I'm only asking you for the x component of this force. So whenever you work through your calculation, whenever you get to the end for your, when you write your F3 vector out here in unit vector notation, then I'm just asking you for the x component, which is this component right here. So I would type in the number minus 2.557 into the little space for the answer on Canvas for this problem.